So let me tell you an interesting story of SDDC, right? So I remember this term SDDC or Software Defined Data Center was first coined by our then CTO, Mr. Steve, in 2012. And he stated that today's data center are typically built across silos of networking, servers, and storage, which pretty much limits the ability of IT to respond to changing business needs, right? So good morning, everyone. This is Purushottam, and I am a part of APJ Partner Readiness team, and a very warm welcome to all of you. So depending on your competencies, I assume that somebody in the audience is very well versed in terms of VMware technology or the native cloud technology. Someone is there who understand VMware not very much, but in a lesser extent, right? So I am trying to keep this presentation very basic. I will start from the basic and I will guide you through the entire product family throughout the VMC or VMware Cloud on AWS or VMware Cloud offering for multiple clouds. Right. So this is the story of SDDC, correct? And let me tell you the today's SDDC reality. So here you can see that in today's world, the customers are using multiple SDDCs or native public cloud, like AWS, like Azure, like Google, like Oracle, Alibaba, IBM, you name them. There are too many, right? And there are various applications and use cases to adopt these multiple SDDCs, right? Like some customers want to avail serverless Lambda functionality from AWS, maybe S3, maybe EC2, correct? And somebody wants to use Oracle Cloud for their robust and industry-leading databases solutions, right? Similarly, someone wants to adopt Google because of the AI and ML based workloads, because of the containers and the Kubernetes, right? And in order to avail all these services across multiple SDDCs or multiple native clouds, customers are bound to adopt diversity of infrastructure, diversity of operations, so many security processes, and multiple skill sets, right? So many diverse platforms, so many distinct processes, so many distinct tools to manage and maintain and operate and secure the entire cloud data centers. But anyways, the customers are dealing with these multiple SDDCs in their own way, correct? But I would say something is missing. Something is still missing. We are living in the world of multiple SDDCs like AWS, Google, Azure, and something is still missing. And that missing thing is the key to make the customers happy, right? So let me help you. What is missing? But first, you help me. Can somebody from the audience please tell me what is written here in this slide? Or if you don't know, then please please say yes or no in the chat box. Can someone interpret what is written here? I believe the people who are listening to me or who are watching this presentation are not able to interpret what is actually written here, correct? So the sentence tells, which was there in the previous slide, that all of you are great sellers. It's so simple, correct? Now you are able to read it properly because it is written in a language which we all know or which we all understand properly, right? It is so simple, but it was not written in the language you understand. That's why there was a problem, right? There was an isolation. So Now coming to the next slide, you would all know that what is missing among all the native public clouds. So as you can understand from the previous slide, all these public clouds or native multiple SDDCs are living in the world of isolation, right? And the missing thing is the common consistent platform, which is missing among native public cloud. And that is the only reason. That's why the public cloud cannot talk to each other, right? And they cannot really move their application consistently or seamlessly from one cloud platform to another platform, right? Because these are inconsistent by nature. The platforms they are using are diverse platforms with diverse operating systems, right? Which are not same. The multiple operational tools are there, which are not the same. The processes are different, and there is a big list, right, of diversity. So what is the solution? The solution is to develop one common consistent platform which can reside in all the public clouds or native public clouds and can easily communicate with all the native services and can easily talk to each other, talk to each of the cloud, right? So with VMware Cloud, we can attain all these objectives in a very consistent manner. And we can use same people, same processes, same tool to operate across public, private, and edge cloud. And this brings the true story of hybrid cloud, right? So VMware is gelling among all the public clouds, right? It is providing you a consistent platform which can communicate with all the public clouds, right? And now to give you a brief idea, so VMware Cloud offers a consistent platform, including the consistent infra. So infra is very much important because our VMs or our containers, whatever it is, are meant for running applications, and that VMs and containers are constructed over an infra. An infrastructure, maybe bare metal infrastructure or a virtualized infrastructure, right? So you need to have consistent infra, right, to run both the traditional virtual machines and the containers or microservices. Secondly, the VMware Cloud offers consistent operations and automation across all the clouds, be it public, private, edge, or hybrid. Correct? And last but not the least, it gives developers the freedom to access the infra as a code using various APIs. Right? So how this platform works, right? So it actually works on the basis of true SDDC model. And a true SDDC model, by definition, it is the one where your infrastructure is virtualized. When I say infrastructure, I mean that the compute, the storage, the network, everything is virtualized and it is delivered as a service and managed by a software console. So here you can see that just a moment. Here we have the bare metal servers, and on top of these bare metal servers, we have a layer of abstraction which is called a hypervisor. Right? Please remember these two terms very carefully. First one is bare metal and second one is the hypervisor. Correct? And on top of the hypervisor, what we are doing, we are creating the virtual machines, right? To run your application, to build your application. And how we are going to achieve this virtualization? We are virtualizing the compute layer, the storage layer, and the networking layer, right? And all together, we are managing it through a software console. This is the definition of SDDC, and this is the basic building block of VMware Cloud in order to attain a consistent operating platform. Let me tell you. So as I mentioned, that we have three components to virtualize your infrastructure. You virtualize your servers, your storage, your network. So we have a solution called VCF, which stands for VMware Cloud Foundation, which gives you the complete virtualization for your compute, storage, and network. So vSphere is meant for compute virtualization, which is the industry-leading hypervisor. vSAN is the software-defined storage and HCI solution, and NSX is the network virtualization or software-defined network. And it is tightly integrated. The entire solution is tightly integrated. All the three components are tightly integrated, and they are governed through a single software console, vCenter. Many of you are aware how to operate vSphere, vSAN, NSX, and vCenter, correct? So by using this approach, ECF is the actual building block for VMware's multiple cloud or multi-SDDC strategy. And we successfully accomplish our vision of any application on any cloud with the help of VCF platform. Correct? So with this platform, VMware helps our customer to build, run, manage, connect, and protect. Build, run, manage, connect, and protect any application on any cloud. And when we talk about build and run, by using VMware Tanzu, as mentioned by Nilesh sir, Tanzu and VCF platform, we use to give our customer the flexibility so that they can build microservices, container-based application on the same vSphere hypervisor, right? This is the very unique feature that we can build the microservices or the container-based services on the same hypervisor on which we are running the traditional virtual machines from ages. This is the very unique feature. You should remember this very, very clearly, right? So now, in order to manage the platform across various clouds or multiple clouds, our vRealize automation and operation plays a vital role. So all the capacity, health, performance related assessments, all the template creations for automations, for self-services, the vRealize product suite can be added to this solution, right? And on the other hand, using cloud health, we can maintain policy, governance, and cost of optimization across all the cloud. And similarly, using the NSX platform of software-defined networking, we can connect across multiple SDDCs seamlessly. And because the security is paramount, so we also offer our industry-leading carbon black solution in order to ensure the intrinsic security. So this is all about the VMware multi-cloud strategy. So by using this strategy, we give our customer a common, consistent, unified platform which runs across the multiple SDDCs or the multiple native clouds which are present in the world, like AWS, Azure, Google Cloud, Alibaba. All these clouds can accommodate our multi-cloud strategy. Is it clear? So far, so good. Is there any question?
Yes, yes, for sure.
Okay, thank you. Thank you so much. All right. Now let's talk about our VMware Cloud on AWS offering. So, which is this is commonly known as VMC on AWS. Correct? VMC on AWS is a jointly engineered cloud service which runs on Amazon EC2 bare metal servers. Remember I told you about bare metal and hypervisor. So here the story comes in that we have purchased or we have taken the bare metal servers from the native AWS, on top of which we have deployed our hypervisor layer. Not the hypervisor of native AWS, but the same hypervisor which we are using in our private data center or in-house data centers from the ages, and that hypervisor is vSphere. So please remember this fact that when VMware talks about multi-cloud strategy, so the basic building block or the foundation is the bare metal servers, and on top of that, the vSphere or VCF platform running, right? So this service is delivered, operated, and supported by VMware directly. So there is nothing to do with the AWS. You need not to, as a customer, you need not to raise a ticket on AWS, then AWS will contact to VMware, nothing like that. It is directly delivered, operated, and supported by VMware. It is available through on-demand capacity and flexible consumption model. And we will talk more about that in the upcoming slides. And it has operational consistency with on-premises. This is a very important thing to understand. Like, what does it mean? So we all know that when we talk about the on-premise private cloud or traditional data centers, we find VMware as a dominant virtualization platform because the vSphere, vCenter solution is an industry-leading solution which captures almost 80 to 90% market share, right? And on the VMC on AWS Cloud, the same vSphere, same vCenter are present. Not only the vSphere, but also the entire VCF solution is available as a basic building block. So as I told you in my previous slide, to attain virtualization, we are using vSphere hypervisor on bare metal x86 servers, right? Because it is the foundational component, right? So that is how we can easily attain the operational consistency with on-premise private data center, and we can seamlessly migrate the workloads to and fro because we have a common consistent platform running both on-prem and on AWS cloud, right? And the beauty of the solution is that it is tightly integrated with the native AWS services, which you can see here. So on the left-hand side, we have on-premise data center, which is again a vSphere-based environment. And on the right-hand side, we have VMware Cloud on AWS solution or an SDDC solution on the cloud. And both of these worlds can be managed through vCenter, correct? And we can offer large-scale application migration as well. And not only the interoperability, we also support the native services of AWS like S3, Lambda, Redshift, you name them. So many services are supported, right? And to talk about the availability, so this solution is available across 17 regions of AWS, and 3 more regions are planned to be deployed soon. So these are Hong Kong, Milan, and US East. And talking about the compliance and the certification, the solution complies with all the regulatory and industry compliances like HIPAA, like ISO, like CSA. So many compliance are there. Now, I believe I have covered a lot regarding this. So let's have a quick look on this. So as I mentioned that we have vSphere as a virtualization platform, right, which runs on dedicated EC2 bare metal physical servers, and uh, it has all the scalability and availability features to help the customers with flexibility and agility. And one thing I want to tell you here, that unlike the traditional native public cloud, in which you create the virtual machines on the basis of a particular VM size, like just like the t-shirt size. Um, Depending on my personality, the size 39 fits to me, but I have no options because in the market, the the sizes which are available are either 38 or the 40 or beyond 40, right? So I cannot customize according to my need. That's why I go to the tailor and ask them to prepare a custom made t-shirt for me. Same is the difference between the native public cloud and the VMware cloud on AWS or the VMware cloud on multiple SDDCs, correct? You can customize your infra as per your need. Anytime if you feel that I need to customize this VM from size 40 to size 39, right? Which is not possible in native public cloud, you can do it in VMware because you have the entire infra with you. You have a better control over the infra. We are deploying the virtualization on top of bare metal servers, and we are providing you the control over the bare metal servers. Those bare metal servers are meant for your application, your data center only. This is the basic difference, that you get the power of customization in your hands and you are not bound for a particular fixed t-shirt size. I hope I am clear. And secondly, if I talk about the vSAN, so vSAN is a software-defined storage solution, which is an HCI-based solution. And this solution is very much tightly integrated in the kernel of vSphere. So it is not an bolt-on approach in which the software-defined storage solution is bolted on the hypervisor solution. The storage solution, the software-defined storage solution is actually built into the kernel of vSphere. This is the key differentiation, right? So that's why it is able to deliver high performance, high IOPS, high throughput. Correct? It is an HCI solution and it has all the industry standard efficiency features like deduplication, like compression, like encryption, you name them. All of the software defined storage features are available with this solution, right? And another critical component is NSX, which is again an integral part of entire ecosystem, and it delivers all the software defined services like logical switching, logical routing, logical firewalling, the IPS, IDS, VPN, and so on. So it acts as an overlay network on the top of your L2 or L3 layer, and it offers all the services starting from L4 to L7. And it not only provides these services, but it also helps determining the network issues, and it troubleshoots them in an effective manner to give you a clear visibility in terms of what is going on inside the entire network, right? And now talking about the management components of VMC on AWS. So we all are familiar with the vCenter, right? We have single pane of glass to manage both of the world, be it public cloud or private cloud or both. You will get the same single dashboard in which your both of the SDDCs will be reflecting and you can play around it. And additionally, we offer solutions like vRealize automation and the operation, as I mentioned, that the capacity, health, performance, the automation, self-service automations, all these things can be attained across all the cloud. And we also offer the cloud health solution, as I mentioned, that it is a tool for having the policy governance and the cloud cost optimization. So you can compare between the clouds on the basis of various workloads which are running across the cloud, and you can actually get the cost analysis that in AWS infra, I am running these much of virtual machines. If I migrate these virtual machines to my on-prem vSphere infra or to Azure or to Google, what should be the cost? What is the difference of cost, and what should be the how would I optimize it? Is there any compliance related issue with my environment? If there is some code which should not be open is open, so there will be alerts to help you that this is violating your compliance. So please close these ports, right? Please restrict the traffic on these ports. So many things you can attain through this cloud health solution, correct? And last but not the least, as I mentioned, we assist you in the bulk migration. So if you have thousands of VMs running in your on-premise data center, we offer free of cost VMware SCX solution, which is WAN optimized, encrypted, to attain the large scale migration from on-premise to VMC on AWS, right? And similarly, we support a large ISV ecosystem, right? And there are multiple APIs which can communicate to our VMC on AWS cloud offering, right? So just to brief you here, VMware Cloud on AWS is a cloud service, right? It is not a perpetual license. It is a service which is subscription based, and this service is delivered uh, and supported by VMware and its partners like you. And talking about the updates, upgrades, and patches. So VMware is entirely responsible for managing, maintaining your entire ecosystem. And as we all know that VMware delivers best-in-class services when it comes to support, right? So all the components related to vSphere, vSAN, NSX, HCH, and even SRM and other components as well are supported and maintained by VMware directly. Customers can approach VMware through 2-3 options which are mentioned here. Like they can go for a live chat, they can raise a ticket in my VMware, or they can approach to global support services, which is GSS, right? So please remember, this is a cloud service, and the platform is VCF platform, correct? So now talking about some benefits of VMware Cloud on AWS. So just tell me in the chat box, how many of you have worked on vSphere, vCenter based environment? Just type yes or no. Okay, great. So we have a combination of yes and no, and there are the majority of people saying yes. They know what is vSphere, what is vCenter. So those who have already having hands-on experience with vSphere platform can tell me how easy is to migrate a virtual machine from one data center to another data center using vSphere vMotion migration, right? So since in the VMC on AWS, the same vSphere platform is running, therefore it just takes a single click to migrate a VM from on-premise private cloud to VMware on AWS cloud or vice versa. So both things are possible. You can migrate your virtual machine from your in-house data centers, which are vSphere based, using the same set of tools, same vCenter, same process, right click on a particular machine, click on migrate, select the destination and uh, the select the compute or the storage resource on which you want to migrate your virtual machine. The same processes are there with this platform, right? So these are the benefits of using VMC on AWS platform. Like you can seamlessly migrate your workloads to and fro without refactoring and re-platforming them. Let me explain you this point. So suppose there is some legacy application running in your on-premise data center, which cannot be migrated on a native public cloud because so many refactoring and re-platforming should be required to run and deploy that particular application on the public cloud successfully, and it takes a lot of time and a lot of effort, and there is no guarantee that that application is going to work on the native public cloud after refactoring and re-platforming. That is why the customers are struggling to migrate their legacy application on the public cloud, right? So by using seamless migration, you can migrate your legacy applications from your public data, from your private data center to your public cloud, which is VMC on AWS, correct? And not only the migration, but also you can develop new applications like modern applications which are cloud native, which are meant to run on the cloud and which are running on Kubernetes platform, container-based application, correct? All these applications can reside in the same environment of vSphere, right? So VMs and containers both can run on the same platform, right? This gives the flexibility to the operations team and to the developer as well, right? So this embraces the culture of DevOps. Like the IT team can use same set of tools like vCenter to manage the VMs and the container infra, right? And similarly, since the APIs are open and you can put the restriction on the users, you can give the authoritative access to your developers so that they may use the infra as a code and they may call their legitimate services through API and they may consume it without any problem, without any interference. Right? They need not to raise ticket to IT that I need these resources to run my container. Please give me those resources. No, everything should be automated. Correct? And similarly, we provide you the consistent platform so you can play around multiple clouds, right? And the solution is very much portable. So as I told you, you can have the capabilities of true hybrid cloud. You can seamlessly move from here to there and to and fro. So this is the whole idea behind the VMC on AWS benefits. So far, so good. Am I going so fast? Too fast? Or is it okay?
It's okay.
Okay.
For me, Purushottam.
So Shita, so Girish and Purushottam, there have been a couple of questions that I see you are answering on the chat. Do you want to just take them up in the interest of the larger audience as well?
Yeah, Girish bhai, can you please please tell me what are the questions?
Yeah, because some of these questions would be relevant to.
Yeah, please. So
I've been answering. Yeah, I've been answering to everyone. Hope you'll be seeing the answer. So I had a couple of questions, but I allow Purushottam to complete his entire presentation, and then maybe we will go through this.
Okay.
Yeah, I'm answering the questions, but
no problem. So if in the interest of audience, if you feel there are some questions which should be announced publicly and answered publicly, so you can explain to the audience what are the answers.
Definitely.
Yeah, thank you. Okay. Yeah. So just give you the quick brief about the AWS configuration, the VMC on AWS configuration in terms of the hardware platform. So in India, we are basically using two platforms, which is i3 Metal, powered by vSAN, and i3 Metal, which is again powered by vSAN. And the basic difference between these two hardware components is in i3 Metal, you can run your traditional or the regular workloads like databases used in OLTP, like high-speed analytics applications. And in terms of capacity and in terms of resources, there is a slight difference between these two hardware platforms. So in the i3 Metal platform, we have 36 cores, and on the other hand, in the i3 Metal, we have 48 cores. Correct? And this hardware platform is meant for running applications like data warehousing, who have random and high IOPS requirement, maybe the distributed file system, maybe the NoSQL databases, right? So, and this platform is very much full of resources like memory and compute and the storage. So on the left hand side, the i3 Metal having 10.3 TIB raw storage capacity per node, and similarly in i3 Metal we have close to 45 TIB raw storage capacity. And talking about the network, we have same network interface, which is 25 Gbps all across both of the solutions. Right. So let me give you a brief details about how it is configured. So in i3 Metal, we have two disk groups, and the first one, which you can see here on the top, the caching tier. So we have two disk groups, one disk group and the second disk group. And in this disk group, we have one caching drive and three capacity drives. So total, we have 8 drives across one host, one physical server, correct? And inside the server, we have 2 caching drive and 6 capacity drive, right? Similarly, if we talk about i3 Metal, we have total of 4 disk groups, 8 drives of 7.5 terabytes. So as I mentioned that when you need more capacity, then i3 Metal hosts are more suitable to you. So 8 drives of 7.5 TB self-encrypting NVMe drives, right? 4 disk groups, and in the similar fashion, one disk for caching in each of the disk group, right? And the rest of the drives are deployed for the actual data operations, for the read and write operations, right? And in the differences in the i3 metal, which is the previous one, we have deduplication and compression enabled. And on the other hand, with this i3 EN metal host, we have deduplication and compression disabled. Right? This is the basic difference. And talking about the packaging and purchasing and the consumption model. So,
sorry, any ballpark figure approximate VMs for each node SDDC?
It all depends on the capacity, on the resources you have configured. But
there's a minimum node configuration, right? Minimum of 2 nodes.
Yes, correct.
Right. Okay.
Correct.
Yeah. See, the minimum exactly the minimum is 2 nodes, and as per vSAN, what we say is a single node can have up to 200 VMs. That is that you may take it as the maximum upper limit for a number of VMs on a single node.
Sorry, I missed you, Girish.
200 VMs.
200 VMs. 200 VMs.
200 VMs on one SDDC.
Yeah.
One node.
One node. Okay.
Yeah.
Depending if it falls within that vCPU and RAM range, right?
Exactly. It obviously
Yeah.
also takes into account that you don't utilize the servers with those 200.
And the overcommit ratio here, can I go? I mean, normally it's 1:2 for AWS. Can we go more than that?
It's up to you.
Okay.
That is one of the USP of this particular service, because when you choose AWS EC2 instance, right, it is all like you will not be able to choose the density. It is like either you have to choose this T2 micro, T2 nano, whatever it is, and then it by default it charges you based on that particular VM. But when it comes to VMC on AWS, the customer can choose his own overcommitment ratio, and he can load the VMs just like how he has been utilizing in on-prem. So the density is up to the customer.
Right. So the equivalent to VMC on AWS would be dedicated hosts, right? And on dedicated hosts, the overcommit is 1:2. That's the max.
Yeah. It is equivalent to dedicated host. In fact, the bare metal that we are using i3, it's actually dedicated, provided by AWS, on which VMware software gets deployed. So the only difference is we don't have a ratio here, and there is no additional charge for utilizing more actually.
Understood. And all Intel processors, right?
Yes,
Since
all
it's
Intel.
SDA. Yeah. Okay.
Yeah. Thank you. Yeah, Purushottam.
All right. Thank you. So we are running out of time. Let me quickly run it through. So this is all about the simple packaging, purchasing, and consumption model. So you can purchase this offering from directly VMware, from AWS directly, or from the VMware certified partners like you. There are certain payment methods which are mentioned here, and the consumption model is 1 year yearly subscription, 3-year subscription, or on-demand subscription. So if some of your customers says that I have a demand for certain resources on VMC on AWS in festive seasons, like in Diwali, in Holi, or whatever it is in the year end, right? So you can provide them the on-demand hourly subscription to fulfill their needs, right? Talking about the life cycle management, so as I already mentioned, that entire patching, the updation of software, right? All these things are taken care by VMware, and the service level agreement is 99.9% for non-stretch clusters which are present in a single availability zone, and 99.99% for stretch clusters which are present in the multiple availability zone. We will cover this topic in more details. And we have global support. And in the software package, we offer a complete SDDC software solution, and which comprise of vSphere, vSAN, NSXT, and vCenter server. And VMware SCX is also there. The login site is there. And as I mentioned, that hardware we use is EC2 bare metal, and you can propose optional add-on components to your customers like VMware Site Recovery Solution, RDR, right? The operations and automations as well. And here are typical 4 use cases while we talk about VMware Cloud on AWS. So the first one is disaster recovery. So a customer is planning for a new DIA, and they don't want to invest in an on-premise data center, and the customer is running on vSphere infra. So this is your opportunity. Or the customer is replacing their existing DR because of some reasons, and they want to go to cloud for the DR solution. So this is the second option, and you can complement your existing DR as well. Second is data center extension. So suppose a customer wants to run some of the application in their in-house data center and some of the applications on the native public cloud or in the VMware Cloud on AWS, right? And they want a seamless, consistent platform between both of the worlds. So this is the use case, right? Sorry. So, and if I talk about the virtual desktop and publish app kind of scenario, the customer wants to run their Horizon infrastructure, which is a VDI solution from VMware, in the public clouds, right? So you can very much offer this platform, and not only the VDI solution, but also a customer can have the test and dev environment on the VMC on AWS platform. The third option is cloud migration, which is probably the complete data center evacuation, correct? Is if a customer is having an infra refresh, is thinking about the infra refresh, and and the customer is evaluating the cloud as well. So you can propose them, if at all the customers are running vSphere-based environment in their in-house data centers, right? So this can be a good use case, because as I told you that the migration and the refactoring and the replatforming is not there with our platform. And similarly, as I mentioned, that if a customer wants to run modern application on the containers and on the Kubernetes, so this solution is suitable for them, as they can run both the VMs and the containers on the same platform. So the manageability is quite easy. They can use same vCenter solution to operate the entire ecosystem. So as I mentioned, there are 2 deployment methods. As I mentioned in the SLA, that there was 99.9% SLA for non-stretch clusters and 99.99% SLA for stretch clusters. So in the left-hand side, we have a cluster of VMware VMC solution running on a single availability zone within a region, right? So then we offer 99.9% SLA, right? If this entire availability zone goes down, then there will be disruptions in the services. And on the other hand, if you go by stretch cluster model, like the customer doesn't want any kind of interruption in their services, so they may go for this stretch cluster options, in which the entire infra is spanned across 2 availability zones, correct? And if one of the availability zone goes down, no issue, all of the workloads are up and running from another availability zone. And talking about the configuration minimum and maximum, so there is a soft limit that there should be maximum 2 SDDCs per organization. Please remember, this is a soft limit and it can be increased. and there can be 20 vSphere clusters per SDDCs, and in a cluster we can have 2, 3 to 16 hosts per vSphere cluster. So we can start from 2 nodes, and we can go with 16 hosts per vSphere cluster. It is the soft limit, right? And in the near future, you will be seeing that this limit will be increased. Maybe 32 nodes or so can be there, right? And the cluster 1, by default, the cluster 1 contains the management VMs. So once you deploy the SDDC, it first deploys the management components, which are vSphere, which are NSX, vCenter, SCX, site recovery. All these components, right, the basic building blocks are deployed in the cluster 1, right? And you must have heard about the storage policy based management in vSAN. So those who are aware about vSAN technology, they are well aware that VMware gives you the flexibility to define the storage policies on the basis of virtual machines, or even on the basis of their VMDK files or the disk files which are there in the virtual machines, correct? So you can apply the RAID policies, you can configure the IOPS limit, all these things you can apply on a fly on the basis of a software console, and it is very granular because you are not limiting the policies to be applied on particular disk volumes, but contrarily, you are able to assign the policies on the basis of per virtual machine, right? So this gives you the flexibility and the granularity to manage your entire virtual ecosystem in a better way. It is very simple and scalable. You can change the policies on a fly. And talking about the network interconnectivity, so how you are going to connect your on-premise data center with your VMC on AWS data center. So there are 2 options. You can connect both of the words via VPN. So I believe L2 and IPsec VPNs are there. And optionally, you can avail direct connect services, right? Both of the services are terminating to NSX edge router, right? And similarly, if you want to avail the native public cloud services on the right hand side, right? So the native Lambda services, native EC2, native S3 services, you can connect through ENI, that Elastic Network Interface. Just understand in the simple way that we have 2 network interface cards. One is for the internal SDDC, which are on the VMC on AWS platform, and the other card is to communicate outside that VMware Cloud on AWS SDDC to communicate with the native AWS services, correct? So this is the closer look about the networking inside the SDDC. So there are basically 2 segments. One segment is your management. So as I told you that the management components are deployed in cluster 1, right? And all the vCenter, NSX, all the virtual appliances, OVA, OVF appliances meant for running your management components are deployed in the management cluster. And for management cluster, we have a separate management gateway. And similarly, all your virtual machines and workloads are deployed on the compute gateways, right? So this is the compute cluster. And in the compute cluster, you can create multiple firewalls, which is accomplished through micro segmentation. So if you don't want this VM to talk to this VM, you can apply firewall policies here on the software level. Similarly, this is the gateway firewall, right? And these gateway firewalls are connected to edge gateway, right? Which is the edge router to communicate from outside world, right? So for north-south traffic, this edge gateway appliance is deployed here, right? And in terms of scalability, so you can use the elastic DRS integration in order to automatically scale your CPU, memory, and the storage across all the clusters, right? And the monitoring interval is every 5 minutes. So every 5 minutes, this solution monitors the entire ecosystem, and accordingly it takes the necessary action as per the predefined thresholds. Correct? And these are 4 options related to elastic DRS, right? So if you want to scale out your storage only, then an additional host with additional storage will be added depending on the threshold. You can optimize for best performance, right? You can define the minimum cluster size, the maximum cluster size, right? So based on the cluster utilization, we will add host more quickly and remove host more slowly in order to ensure the best performance, correct? And on the other hand, if you are trying to optimize for the lowest cost, then we are going to add host more slowly, and we are going to remove the host more quickly in order to ensure that there is a cost optimization for your environment, right? And another option is rapid scale out option, right? So based on the cluster CPU and memory utilization, we will add multiple hosts at a time, and host must be removed manually when no longer needed. So the automation will not be here. You need to manually remove the host. Talking about the encryption. So the data at rest encryption, data in transit encryption, the data in motion encryption, all the encryptions are very much possible with this platform, which is VMC on AWS, right? And you can use native AWS KMS services. You can use the KMS provided by VMware, or you can use a third-party KMS solution, which is, I think, KMIP 1.0 compliance. And similarly, if I talk about the custom core CPU count, so think about a scenario. Suppose you have certain database software available with you, which runs for which you need only 10 cores, correct? And by default, with VMC on AWS solution, we give you the full host with certain number of cores, maybe the 36 cores per server. So in order to give you the cost optimization in terms of your databases and any other software which are core sensitive, you can lock the rest of the code in a particular host, so that the only relevant cores are consumed once you run your software solution, right? Now talking about the vCenter Cloud Gateway appliance. So what is the Cloud Gateway appliance? So you must have heard about the hybrid link mode in vCenter, correct? So this is a similar kind of scenario where you can deploy one Cloud Gateway appliance of vCenter either in the VMC on AWS or in the vSphere on-premises data center. And in order to integrate your on-prem SDDC and the VMC on AWS SDDC, hybrid link mode is used. So as I mentioned that using a single console with the help of hybrid link mode, you can get the dashboard related to your on-premise data center and your VMC on AWS cloud data center, right? And similarly, you can leverage the vCenter content library where you can create the standard contents, and you can You can deposit those content in maybe in the on-premise data center, and you can tell all the SDDCs to subscribe those templates so that there will be a standard deployment of the virtual machines through the common VM templates or the ISO image or the OVA OVF template. And similarly, you can have the scripts as well in the content library. And as we all know that vRealize operations is always meant for capacity, health, and performance related dashboards. Customized dashboards you can create using vRealize operations, which is powered by AI and ML. So you can have right sizing recommendations, workload optimizations, you have the capacity assessment, right? You have the intelligent remediation, right? All these things are possible through vRealize operations. So if you have vRealize operations deployed in your on-premise data center, you can use it on your VMC on AWS environment as well. Similarly, the log insight is there for having root cause analysis related to your entire SDDC infra. It will give you all the details in the log format, so that you can identify the problems related to your network, related to your applications, and you can do a root cause analysis and probably troubleshoot the actual problem. Now, talking about the data protection partner strategy. So you can bring any third-party data backup solution on VMC on AWS. And since we have an open API, which is called VADP, the storage API for data protection. So this API can talk to the backup software and give the information of virtual machine, and the backup software can be deployed to fetch the backup and deposit it to a destination storage. And the destination storage can be your EC2 based backup appliance, or you can run the backup solution or the backup virtual machine on VMC on AWS itself, and you can mount it to a S3 repository. So the backup repository will be S3, and your backup software will be running on VMC on AWS, and it will deposit all the backup data in the S3, right? And here we use Elastic Network Interface to avail the native AWS services, ENI. And to mention here, no ingress or egress charges within the same availability zone. This is the very unique point. Like, you are not going to pay anything if your data is moving around the same availability zone. Now talking about the maintenance and support, on the left-hand side, VMware will provide all the management and all the patching, all the firmware upgrading, all the updates, all the maintenance tasks will be done by VMware on the physical hardware like ESXi host, the vSAN, vSphere, the NSX. All these things are taken care by VMware itself. And on the right-hand side, customer needs to create their own AWS VPC, right? And they need to they need to configure the management and compute gateway, whatever traffic they want to allow or disallow, whatever it is, they need to configure by their own. Customer will configure their virtual machines, the guest OS, the VM tools, the guest applications and data, and the compute and the storage policy. Depending on what RAID, what IOPS are required per VM, they can have full flexibility to do that. But they are not going to access the physical host and the management part. Okay, so by using this website, you can see whatever is going around in the AWS VMC on AWS roadmap. So what features are upcoming, what are planned, what are in development phase. So all these things you can get from this portal. And so this is quite common slide. These are some key differentiators that when you position VMC on AWS, then you can tell your customer that there won't be any application refactoring if they are running on native vSphere platform. There shouldn't be any infrastructure retrofit, and the platform is quite consistent. The operations are quite consistent. The migration of the VMs can be cold, can be hot. The bulk migration is possible. The migration will be WAN optimized, and they can stretch their L2 network in order to perform seamless migration, right? And we have enterprise grade availability and optimization. We have good hardware, robust hardware with great performance. And we have elastic policy driven resource management where you can scale up, scale down accordingly. So many things are there. These are the differentiators, and these are certain economic value drivers. So first of all, you need not to have any refactoring, replatforming of the platform. So here you save at least 57% of migration cost. And since your people are trained with vSphere, vCenter platform or the vSAN and NSX platform, so there won't be any issue for them to learn the new technology of the native public cloud. So there are 71% saving in operations and training. And similarly, the platform is very much flexible. So you can move your workload from on-prem data center to your public cloud, whatever it is, and you attain the operational efficiencies, right? Thank you so much. I had overrun. So if there are any questions, Girish bhai.
Yeah. So I have a short poll. Let me know whether you want to do it now or have a small break and then have the poll later. Maybe you can put it on chat. People who want to do it now. Hello.
Doesn't look like anyone wants to do it now.
Yeah, I got one answer from Ninath. Thank you, Ninath. Yes.
How many questions do you have?
I have like, it's a single poll with 4 questions. Just a revisit to whatever we spoke so that we refresh out the most important stuffs that were discussed. Okay, we got one.
I think let's take a break, Girish. Let's take a break and connect back at 11:50. Would that be fine? And then
yeah, I have a 10-minute timer that will come up. Be in the session. Just take the break. Once we are back, we'll start with the poll and then we will continue on with the next session. Thank you. Hope it has been relevant for you all, right? Because we have asked you to invest 2.5 days of workshop, I think a couple of sessions. Hope it has been relevant. Let me start off with the 3rd session. Obviously, this session is going to be an extension of whatever Purushottam covered in his previous session. This is more to do with VMware Cloud, but let me take it to the other hyperscaler as well. So let me give it a very clear picture. There are questions that comes out like why VMware Cloud on multiple hyperscalers? Why not just one cloud? The main answer that lies behind is we want to give the customer the freedom of choice, but it doesn't mean we will create a competition across all these cloud vendors. If you ask me a choice, is it VMC on AWS or is it Google Cloud VMware Engine or is it OCVS that we support? Today, we have the option to sell VMC on AWS only from our side. But when it comes to influence the customer and advocate the customers, we leave it to the customer. We don't want to say that this is best or that is best. We just want to give everything that is there on the plate. Let the customer choose basis his need, because over a period of time, what we feel is most of the customers will have more than one cloud. Just like how every customer started with one small data center and today there are many customers running multiple data centers across the regions and across the geographies. Similarly, you will see customers running multiple clouds, and they may want like cloud level isolation, where one cloud fails, I get the services running from another cloud as well, something of that kind. So given that as an option, we want to keep it simple to customers, that we have the baskets available in front of you. You pick and choose the one which is more relevant to you. That would be the answer exactly. So let me start with the VMware value proposition. This is something that we have been speaking for ages now. At least I am seeing this slide for 8 years. The basic stuff that that is underneath the entire VMware offering is that we want to support customer in their digital transformation journey and provide the foundation that will be like help the customer in their transformation journey. So for this, our foundation or our solution that we actually pitch to the customer is any application, let the customer run as existing application or the new application or the new gen cloud native application. It should be able to run on any cloud, no matter whether it is private cloud, edge cloud, or public cloud, and different sorts of public cloud. We will be able to run them there, and all this application is existing to provide to be provided to end users or maybe to the end customers, right? So we want to give help customers provide these applications running on any cloud to any of the devices anywhere across the world. So when we say any, the important thing that goes to customers' mind is, what about my security? You are giving me any, what happens to my security? We give a promise that security is completely intrinsic throughout this entire pillar, and we will be able to deliver them seamlessly across all the cloud. That is exactly what we say is simple answer to this is, we want to help customer build, run, manage, connect, and protect any application on any cloud and deliver them to any device with security intrinsically built into every of these particular pillars. This is exactly VMware's pitch, and I would expect you all to memorize this pitch, and whenever you feel that you position VMware solution, this should be the first thing that you actually pitch to a customer. Let me take it forward. So what does this bring? What does this any stuff brings to the customer? Now, we have something called VMware Cloud Foundation. This is the ester here, we call it as software defined data center. VMware termed this coin in 2013, and then we renamed it as VMware Cloud Foundation, which is nothing but a private cloud stack that we were offering to customers before our public cloud came into force. What we have done is, we have taken the same cloud foundation that is built on the private cloud and took it to the public cloud as well, so that it is seamless. You get to have same vSphere, vSAN, NSX running not just on your private cloud, but also any public cloud of your choice. So what does this bring is, number one, it brings consistent infrastructure to customer, which means if he wants to run a virtual machine that is running on-prem, he wants to move it to public cloud, all he has to do is just right click and say, let me move it to public cloud. That is one thing. Second is, he can use the same templates that he has created on premise and use the same templates and deploy it on any of these clouds as well. So there is no need of any reimaging or refactoring or replatforming that is needed for any of the customers, because customers today are finding challenging to land on the cloud. We give an infrastructure that will allow customers to easily land on the cloud and expand using all the native cloud services. That is exactly what we speak about, consistent infrastructure. Next is, since the infrastructure is consistent, the operations that is performed on top of them, let it be governance, let it be automation, let it be operations, visibility in terms of metrics, logs, everything is consistent for the administrator who is sitting and monitoring and managing this entire infrastructure. We don't need separate silos of administrators sitting and managing them separately. That is the second thing. And one more stuff is networking, which is very important, right? When I'm speaking about multiple clouds, how will I manage security? Should I deploy different security parameters everywhere? I have something called as a compliance. This has to be by security everywhere. So what happens is, customers will try to maintain different security parameters here and there. What VMware Cloud Foundation or the VMware Cloud Story brings is, he has a consistent networking where workloads, no matter where they go, take the policies and the configuration along with them and jump to the cloud. And when they are pulled back, which is very hard using a normal native cloud. But in VMware terms, we can pull back the VM back to on-prem, and yet again, it will follow all the security and the network parameters just the way how it was running on public cloud as well. That is the consistent networking that we are speaking about. With this, on the overhaul, what we are actually providing customers is a consistent developer and a end user experience. This is exactly our story when we speak about VMware Cloud. So why multi-cloud? Obviously, I told multi-cloud is to help customers choose the one that they want. But at the same time, today we see many customers are having multiple clouds. If I take one of the largest ITAS company in our country, they have almost like 3 clouds apart from the VMware Cloud on-prem, which is running on some 7 data centers. They have 3 native public clouds that is running, and there is a 4th native cloud vendor who is actually at the gates trying to sell their cloud platform as well. For this customer, what I see is they have a VMware infrastructure for which the administrators almost like 150 people are sitting and administering, and then they have silos of people maintaining the other clouds as well. So today it's already a reality, but why customers are going looking behind all these clouds? We all know one cloud is good for everything, but why do we need to have multi-cloud in customer infrastructure? That is because every clouds are pioneered in providing service of theirs. Take Oracle Cloud. Oracle database license cost comes down if you choose an Oracle Cloud. Similarly, if you take Azure, the hybrid program, right? The hybrid licensing program, where you can take the licenses and use it on public cloud as well, the Windows licenses and other stuff, SQL licenses, etc. When we speak about AWS, they are pioneered for all the services that they provide, like Lambda, Kinesis, AWS, Code Pipeline. There are many stuffs that AWS provide. Similarly, if you take VMware, we are good in data centers, private data centers, and at the same time, the desktops, the VDI solution that we provide, the networking and security solution that we provide are all something that customers are interested. So if you see customer as use cases to adopt this multiple clouds. So what VMware wants to do is we want to be the center pillar who can connect all these clouds together using a consistent infrastructure, and thereby allow customer not just consume infrastructure as a service, but also expand, cross the boundaries and connect to these native cloud services as well, and see if their applications can run on those native services as well. So that is the main reason why VMware gets into many cloud. It is the one and single reason is the specialities that these cloud bring. And that is exactly the reason customer is also looking for multi-cloud, not just because of economics or cost. Let me take it further. So what is the hybrid cloud solution that we are speaking about? Just revisiting the solution on premises. Most of the customers run vSphere. We have almost like 500,000 customers across the globe and somewhere close to 1 billion workloads running on VMware vSphere today. These customers, there are many people who have adopted vSAN only, NSX only, or a mix of all vSphere, vSAN, NSX put together. So vSphere is our compute platform, vSAN is our storage platform, and NSX is the networking, software-defined networking component. And all these things are maintained and monitored using vCenter, which is our single console to manage the entire infrastructure. This is how customer has been traditionally running their on-premise data center. Now, when they want to move to cloud, what happens is we actually give the same infrastructure, the same vSphere, vSAN, NSX, vCenter, all your automation and operation, which is nothing but a vRealize suite. We give the same stuff on the hyperscaler bare metals and allow customers to connect these two infrastructure either through VPN, which is an inbuilt solution available as a part of NSX itself. You don't need to go for a separate VPN client or something. Or if the customer has his own direct connect or maybe any of his existing connectivity to public cloud, we can reuse them as well. And then what we do is we link the vCenters that is deployed on the cloud and on the prem as a single vCenter. When I say single vCenter, it still are two vCenters, but the database will be one single stuff, so that when you log into a central location, you will be able to monitor and manage both the vCenters with all the role-based access control permissions that is available. But the story doesn't end there, because just by giving infrastructure on cloud, that is not what customer is looking for. This only solves one problem for customer, landing on the hyperscaler, which is very easy because I can just lift my applications, put it on cloud. It runs the same way how it was running on private cloud. But now what happens to my native services that the cloud vendor can provide? That is exactly where the VMware solutions can integrate with most or maybe all of the hyperscalers' native services and seamlessly connect to them and coexist with them. That is exactly the story that we provide when it comes to our VMware hybrid cloud story. And most of the hyperscalers are there globally available. So we also follow a similar data center today. If you see, Oracle Cloud is already available in India. Google is available in India. VMC and AWS is available in India. We have VMware Cloud on Dell, which is an edge cloud. Again, that is available in India. AWS, Azure VMware Services is the only thing that is not yet in India, but we are looking soon for it to be available in India by end of this year as well. So this is our story when it comes to hybrid cloud solutions. Let's see each and every solution one by one. So number one, when we speak about Oracle Cloud solution, again, it's a VMware SDDC running on the bare metal of the Oracle Cloud. It's on demand. Customer can choose when they want to activate, and they can activate, and they will be able to scale out all the functionalities that typically a cloud will provide. It's all applicable there as well. And customers will be able to connect their on-premise infrastructure to the cloud and seamlessly migrate their workloads to cloud or bring them back to on-prem as well if there is a need. And Oracle Cloud in India is available in Mumbai. It's there already. Sorry, it's in Hyderabad. Oracle Cloud is already available in India, Hyderabad, and it uses the bare metal OCVS host. So this is how the infrastructure. This is slightly an older deck, but I think this is more or less the same even today. So we should be worried about India region, 2 data centers, Mumbai and Hyderabad, which means if the customer opts to have Mumbai as their active data center, they can have DR on cloud, Hyderabad as well. Or maybe they can run their data centers across these 2 locations. Apart from that, if the customer is looking for a DR out of India, provided they are not under the guidelines or data sovereignty kind of issues, they can also replicate data across regions as well. This is completely possible with respect to Oracle Cloud or any cloud to be that fact. So what is this Oracle in OC? We call it as OCVS, Oracle Cloud VMware Service. Is actually what we call the Oracle VMware solution as. It runs on bare metal instances, just like how VMC on AWS is. The key features are bare minimum 3 hosts are mandatory. There is no 2 host concept in Oracle Cloud as of now. Each host has somewhere close to 52 cores of CPU as against 36 and 48 that you have on VMC. 768 GB of memory per host, and roughly 50 terabyte of raw capacity on a single host, which is like this. You can treat this as a storage dense configuration. And by default, OCVS provides vSphere, vSAN, and NSX as a part of the subscription. The thing that you should be looking for is OCVS is a solution that is sold by Oracle to customers. VMware only advocates the customer. VMware cannot sell it directly. It is either the Oracle partners or the Oracle themselves who can sell the solution to customers. So what happens is the entire support of OCVS is also taken care by Oracle directly, and Oracle has a backend relationship with VMware if there is an escalation to actually elevate the case to us. So what happens is customers are customers of Oracle, just like how VMware has been selling OEM license, right? You can treat Oracle Cloud VMware service similar to it. So what is available as a part of OCVS? Typically, there are 3 options that is available in terms of software. They support 6.5 update 3, 6.7 update 3, and 7.0 update 2, which is the recent release of vSphere. So vSAN also follows whatever is vSphere, and NSX is pretty much 3.1, which is the latest version, is still supported as a part of the Oracle, and it is NSXT, not NSXV. When it comes to pricing, how Oracle provides calculates pricing, 4 options. Number 1, they do have a hourly pricing for customers. Minimum 8 hours of usage per day is what they expect from the customers. Second is monthly billing is applicable, where customer is looking for like, I want to run certain workloads for 1 month and close it off. They have a 1 month committed host runtime that is possible. There is a yearly option where the customer can commit for 1 year. And if the customer looks to migrate their entire workload and completely run on cloud, they can even look for a 3-year model on Oracle as well. One more thing I just wanted to highlight, which I forgot to put in the slide, is on the responsibility. What is Oracle responsible for and what is customer responsible for? Typically a different use case than what we saw in VMC. Here, the support is provided by Oracle. The entire instantiation of the cloud, say for example, the activating the cloud on a click of a button from the customer, is all taken care of automatically by Oracle. Once the cluster is ready and deployed, the entire control is transferred to the customer. So the customer has to manage the entire cloud. It is not offered as a service post deployment. As opposed to VMC, the entire management of the cloud is taken care by VMware. Customer only creates his workloads on top of it. Here, if there is the customer has to manage just like how he has been managing his existing data center. And if there is any problem, he can log a case with Oracle and get it supported. That's the only difference when it comes to VMC on AWS and Oracle. Let me jump into the next cloud, which is Google Cloud VMware Engine. Yet another same story, runs on bare metal again. This is not any shared instance or anything. All our story is running on bare metal instances only. So there are only 2 bare metal instances. Either it can be on demand or it can be a committed model of dedicated bare metal instance. So again, you can connect the data centers, private and the public cloud data centers, or even public and public cloud data centers as well. Say for example, if the customer is running Google Cloud and he wants to run another SDDC on Azure Cloud or a VMware Cloud on AWS, you can still have a connectivity laid between Google and VMware Cloud on AWS. And tomorrow, if he wants to migrate a VM from AWS to Google, it is all about right-clicking the workload and migrating to Google. It is such simple, is what we are speaking about. Such kind of configuration is possible across all the clouds that is available. And once you land on the cloud, you have the option to extend to the native cloud services as well. Here, the entire solution for Google as opposed to cloud is owned, operated, supported, and sold by Google and its partners directly. The hyperscaler clouds, it is always sold by the cloud vendor directly, and this is offered as a complete service. When I say complete service, the entire deployment, the support model, the operation in terms of upgrades, patching, everything is taken care by Google directly. It is not like Oracle, where post the installation, the updates and patches comes back to the customer. Here, the entire control is with the Google. Customer has to just run his workloads on top of it. And that is how the entire Google Cloud engine is designed. Now, with respect to nodes here, again, we have one node currently available as a part of a Google offering, which is VE1 standard 72. Typically, this is a 36 cores is what is available, 2 into 18 core CPUs, 768 GB of memory. This configuration, by the way, doesn't change. This is the configuration that is applicable by default to all the hyperscalers, sorry. In terms of storage, we provide somewhere close to like 19 terabyte of usable capacity, 6 into 3.2. The 2 into 1.6 is typically for caching and performance. So 19.2 terabyte is the raw capacity per node that we provide. And with respect to networks, we provide 4 25 GB network cards, which is actually like 100 GB of throughput is what you can expect. from each node that is deployed on Google Cloud VMware Engine. Again, Google Cloud is available in India. This is in Mumbai that is available. It's just single region that is available within India currently. It is operational from mid of June. So it's if you go to Google portal, you can see Google Cloud VMware Engine. You can do sizing, calculate in terms of cost estimation, etc., can be done on their portal itself. And the software that is provided as a part of Google currently is slightly behind 7.0 U2. It is 7.0 U1 that is actually provided. We are expecting this to get updated as well soon. And NSX is 3.0, and they also provide an HCX by default along with the solution, which is 3.5. Let's speak about what is HCX and other stuff in our future slides. But you just imagine that there is a component called HCX that goes in with all the cloud VMC VMware Cloud story. You buy any cloud, HCX will be a software by default that is available. And the responsibilities, as I told you, customer responsibility is strictly with respect to management of his operating system, apps, consume the entire cluster that is deployed, policies, configuring all those network VLANs, etc., ensuring that all the role-based access control for his internal entities. That is exactly, and maybe the scale out and scale down policies are something that is expected to be done by the customer. Google takes care of the entire infrastructure, providing entire data center as a service, ensuring that everything is deployed, and it is also taken care in terms of upgrades, patching, etc. So entire solution in the backend is controlled by Google as a whole. Any questions, please post it on the chat. Purushottam will be able to answer them, or I will take it up at the end of the session as well. Let me come to the third hyperscaler service, which is relevant to India, Azure VMware Service. I should have put a star here, not yet available in India. It is available across the globe currently. In India, we are expecting Azure to be available by the end of this year, maybe December, January timeframes. You should see Azure getting launched in India. So Azure, yet again, the same story. You can use ExpressRoute, or you can use SSL VPN, or you can use the L2 VPN capabilities of NSX to extend your on-premise data center to cloud. And when I speak about on-premise data center, it is not mandatory that the customer should have the same vSphere, vSAN, and NSX stack. If a customer is running only vSphere and he doesn't have vSAN or NSX, still he will be able to expand his data center or extend his data center to cloud. You might ask a question, does it applicable to customers who is not running a VMware at all? Definitely. That is also a customer who can still get onto any of this cloud. Say, for example, if the customer is running a KVM infrastructure or maybe a Hyper-V infrastructure, can we migrate them to cloud? We do have solutions that will help customers to migrate them to cloud seamlessly as well. And with respect to availability, India is a missing link here, but we have most of the US, Europe, and the Asia Pacific that is covered as of now. India soon to be launched. Most of the certifications with respect to cloud is available as a part of Azure. And when it comes to deployment, obviously Azure gets deployed on the AWS region. Under the resource group, you may have to have a resource group and subscription, etc., and it gets deployed within that particular resource group, and it can also extend seamlessly to the customer created resource group where he will have his native Azure services that is running, and he can have the connectivity through all this global reach and stuff to actually extend these services to Azure native services as well. And when it comes to Azure's availability in terms of VMware solution, it is still not in 7.0. It is all 6.7 as of now. But soon there is an update that is that should be available for Azure to move to 7.0 version of vSphere as well. And the hardware specifications that goes in the backend with respect to Azure is AV36 instance is the type of the instance that we are speaking about here. It comes with 36 cores, 2 into 18 cores CPU, 576 GB of memory, in which 50 GB is reserved for all these VMware components, and roughly around 15 terabyte of usable capacity per node, and 50 Gbps network throughput with a 2 into 25 Gbps network card is what is provided on each of these nodes. Minimum 3 nodes is what is applicable in Azure as well. 2-node form factor is only supported on VMC and AWS. Rest all clouds, it's always 3 nodes. And this is how it looks like. 3 hosts. The configuration comes to roughly around raw capacity of 46 terabyte, and we support up to 96 hosts with respect to Azure. So overall, like 1.4 petabyte of storage and somewhere close to 49 terabyte of RAM is what we can provide in a single SDDC in Azure. Similarly, in Google Cloud, you can extend up to 64 nodes. Same with respect to Oracle also, it is up to 64 nodes, but Azure supports 96 node cluster as well in a single SDDC. With respect to responsibility, you can imagine this more or less equivalent to what Google is offering. Sold by Azure and sold by Microsoft partners. VMware advocates this with the customer. It is completely deployed, managed, patched, updated by Azure directly. Customer has to just do all those configuration with respect to networking, security, and with respect to OS and applications. That is the only responsibility that a customer would have, would need to have on a Azure VMware solution. This is this is about all the hyperscalers that we have. Any questions? Please come forward and you may ask it now before I move on to the sizing. Any questions, team? Are you all with me?
Yes. We are all okay. I mean, till now we are okay.
People are tired, Girish bhai.
Oh, tired. Okay. Then it's
They need
something.
They need some break.
Hey, just now we had a break for 20 minutes back here. Okay. Let me just go and get into the sizing for VMC. Very important session coming up, this one. Just a minute, let me just share my screen. Okay. How many of you have done VMware sizing in the past? Maybe a short question. It can be even just a vSphere or maybe vSphere plus vSAN. Can I have some answers, please?
Sorry, Girish, I didn't understand your question.
Yeah, anyone had designed a VMware solution in the past? Sizing, how did you, whether you have sized it in the past for some customer?
Not on the VMC, but yeah, on the on-prem solution, yes.
On-prem solutions, yes, that is exactly. I'm asking about on-prem solutions.
So 2 years from Gunjan and from Ninad, they also have done the sizing for VMware.
Okay. Let me just take it forward. So when we speak about VMware sizing, typically there were lots of tools that VMware provides, right? The most commonly used tools are live optics, number one, and we have something called RV tools. You would have used these things in the past, right? RV tools is
RV.
Sorry.
I said I used RV tools. Yeah.
Mainly. RV tools. Okay. Yeah. So RV tools is something that is readily available. It is available on the website. People use it for ideally for inventory collection, and you will have a bit of configurations in it by which you can do the sizing. The more scientific way of sizing from VMware, earlier it used to be something called VMware Capacity Planner. Sometime way back in 2012-13, we used to have something called Capacity Planner. Then recently, after merging with Dell, we introduced a tool called Live Optics. So Live Optics is a web portal that will be available for customers, partners, everyone. You can just register yourself. You can just see this. I hope you are able to see the screen. This is how the Live Optics portal would look like. We can have a deep dive on live optics. If someone doesn't know live optics, please put a mail to us. I can come down and help you understand the entire live optics story on how to gather data and etc. etc. I don't want to take it in this session, but definitely we can have a one-to-one session with you all to actually demonstrate on live optics as well. So what happens with respect to live optics is it's a good little portal where you can request capture to a customer, which will automatically send the binary. It's an MSI file that goes to the customer email ID. He has to just download and run it from his local desktop. Once he runs it from the local desktop, it will ask you for the vCenter name or the physical host name, whatever is applicable in his infrastructure. He has to just give the IP address, username, password. It will collect data maybe for 1 day, 2 days, 3 days, up to 16 days or 10 days, sorry, 14 days. It can actually collect the data. Once the data is collected, it will be stored in a format called .siokit. It is an extension, file extension that gets stored on the local laptop. If the customer feels, okay, I don't want to do all these things, let it go to the internet automatically, he can just enable internet and the file will reach automatically the dashboard as well. Once it reaches, you will be able to see all the data applicable as a part of wherever it has got completed, you will be able to see the projects here. And inside any of the project, let me just go to any of one of the project and you will be able to see what is the data that has been collected. It will give you a clear information on what is the CPU utilization capacity in terms of storage, memory, network throughput, how much writes is happening, what is the IOPS, and you can also deep dive and get into individual host and individual virtual machines as well. It gives you a data about the entire infrastructure, top to bottom. So what we can do is we can use this particular data, take an export of the data, maybe download it to an Excel and use the Excel file to actually size our VMC. Earlier, there were tools that were completely integrated with respect to VMware. We can use the Live Optics project ID and size for on-premise solution. For cloud, as of now, that is not yet available. You can't directly have an integration. You may need to manually export the data using the Excel file and come down to the VMware Cloud Sizer. Similarly, RV tools, you will get an Excel sheet, right? You can use the Excel sheet and the VMware Cloud Sizer portal will be able to ingest them and give you a solution. Now, when I speak about VMware Cloud Solution, you can just mark this particular portal. It is vmc.vmware.com/sizer. Is actually the portal link where you will have the access to the sizing tool. So just have a note at it. It is all available for everyone. There is no username, password or anything that is needed here. So there is a quick sizer available here where let's say, for example, if the customer is expecting a solution just rather face to face, he's asking, okay, let me tell me how much nodes would be needed on the cloud and other stuff and all. You can just use this quick sizer and come back with the numbers. So there are certain things that you should actually keep in mind when you do a sizing for VMC. Number one, don't take the mindset of on-premise. Typically, this is something that I have seen. What I have seen people doing on-premise, I will take a RV tools export. It will say that the customer has somewhere close to like 500 vCPUs. We will do a 1:2, which is a calculation by default that anyone will do. 250 virtual cores, 1 terabyte of memory, and customer will have somewhere close to like 50 terabyte of storage capacity that is allocated, not used. And what the customer will say is, I want to use it for next 5 years. So I need a buffer of 10% per year, which is 50%. So 250 cores will automatically become somewhere close to like 400 or maybe even a 500 cores, and we will do a sizing. This is typically how the sizing happens on-prem. Does the same sizing applicable to cloud as well? Definitely. Never ever do similar kind of sizing, because what happens on cloud is you should size exactly to what is the average utilization that the customer is seeing. Say, for example, if the customer has a 24-hour window per day and he works only for 8 hours, rest of the 16 hours is not going to use any of his workloads at all. Let's say that he's not a 24/7 entity, or even if it is a 24/7 entity, Peak time, the utilization goes up to 80%, but typically it hovers around 30% every day. What happens is only for that 8 hours, there is an increment of 30-40% of utilization, which the customer can have an elastic policy where the nodes can get added within 15 minutes, run those instances, and once the peak load goes down, the instance can go down. What happens is customer has to pay for those instance only for those 3-4 hours when the instance has kicked in. For the remaining hours, he doesn't need a dedicated committed instance or reserved instance at all. That is exactly the plan or the sizing that we should do for any customer when we speak about cloud. So always work on the average first as a target. Second, never ever factor for HA, because you factor for HA, don't factor for HA. The availability commitment is 99.9% that is provided by VMware. It is a guarantee. When there is a guaranteed SLA that the customer is accepting, the N+1 concept may not be needed. You can completely get away from them. Third, when you size a data center today, storage is very important. If you see, customer will say, I need 100 terabyte of storage. In this 100 terabyte of storage, you will see actual production data is not 100 terabyte. It might be around 20 terabyte. The remaining 80 terabyte may be files, maybe in low critical, low access to data, and sometimes backups and other stuff, right? This is how it happens. Try to factor 20 terabyte from the VMware Cloud and push the remaining 80 terabyte maybe through a S3 or maybe to some low critical or a high efficient and low cost storage like EFS or maybe a blob storage kind of thing, to ensure customer consumes native cloud services for those particular storage, and the high cost storage which is running on NVMe is applicable only for production workloads. Hope that is clear, right? Any questions?
I have a question, Girish, mainly around your example is really valid about the first utilization, but that is mainly around the VDI solutions, right, Girish? Because if I'm talking about the production environment, if it is serving for any, it should be up across or 24/7 all the time. From the sizing perspective, if I'm understanding correctly.
Yeah, so from the sizing point of view, what happens is typically why customers are, every customer will be okay with working on the average utilization. Why peak utilization is because they cannot add this additional node as and when it is needed. In on-prem, they have to procure, they have to get from the get the budget approved and other stuff. And over a period of time, what happens is it takes around 3 months for them to get this hardware. So that is the reason customer on-prem will always factor for those buffers and other stuff and keep it ready. But in cloud, what we provide is a host addition doesn't take more than 15 minutes. 15 minutes. So the auto scaling concept will trigger automatically and add these nodes to the cluster whenever it is needed. So if you add these nodes and keep them available for entire 3 years, the cost for that node is for 3 years. But if the customer says that my peak is only for 2 hours, what happens is he just needs those nodes for 2 hours. It can be removed later. So if you see, it almost brings down your cost from a 24-hour model to a 2-hour model, which will definitely impact his TCO and ROI at greater lengths. That is exactly the reason why we are saying size it for average and not for peak. But if you feel that the peak is like 24 hours, I am seeing 80% utilization, then we can't get away with it. Then that is his requirement. Definitely you need to size based on whatever is the average. Now the average is, new average is 80%. So you have to size it that way only. But if you feel that the average is very low and there is an occasional peaks that is happening because of maybe some EOD or maybe month-end kind of transactions, then definitely take that apart and let it happen only maybe during let it happen during the scale out process. That is exactly what I wanted to say.
Yeah, understood. Well, one last question, Girish, around that.
Yeah.
When we initiate the discussion with customer, they will say, like, okay, my requirement is for 200 VMs. So can you please build a sizer around that. So is that a correct way of taking the virtual machines load in this, the VMC sizer, or we need multiple data inputs to come up with the correct size?
I'm just getting into that. Let's get into this quick sizer first. Maybe this will answer your query.
Fair enough.
So let me get into the quick sizer, where we have like workload type, couple of options. One is general purpose. Typically all the normal workloads, if you are looking for a database workload, you do have the option. And if it is a VDI kind of workload, obviously you have the third option. Let me get into a general purpose. And as you were asking, let's say that the customer gives around like, I have some roughly 200 VMs running on my on-prem. There are customers who will allow you to do an assessment. There are customers who won't. You may have to go with the data that they have. But still, try to get the data, something like what is your average utilization and other stuff and all. That would be more or less needed. And once you have the total number of VMs, the next important stuff that you would need is CPU, memory, and storage. So when we get into CPU, first, maybe for the sizing sake, you should have a density ratio. Whether it is 1:2, 1:4, 1:6, whatever it is. Typically for a general purpose workload, my suggestion will be start with 1:4. If the customer is saying I have plethora of workloads, certain database, more applications, multiple web servers and infrastructure servers, 1:4 is a very good thumb rule that you can take for cloud. If it is a database workload, try to stick to 1:2 or maybe even 1:1 at times, but 1:2 should be good for a database workload. And if it is VDI, there are multiple options. You have a 1:8, you have a 1:12, and you have a 1:6 as well. It depends. So here for general purpose workload, typically 4:1 is a very good ratio. So I'm taking vCPU to pCPU core is 4:1. Now, in terms of vCPUs per VM, you have an option either to put the average vCPU per VM or you have the total vCPU per VM. Let me say I'll go with total. So you may have to ask this question to the customer. What is the total vCPUs that you are factoring currently across this 200 VMs? And go with this rule of thumb, something I've seen this not happening with most of the customers. They always try to, if there is a 16-core vCPU, 16-core server that is available in physical, they will try to create a VM with 16 vCPU. That's not the ideal case. They should not be doing that at all. So what happens is typically a 2 vCPU machine will be 60% of the workload in a customer base. 4 vCPU is the remaining 25%. 8 vCPU might be roughly around 10%. And only 5 or 4% of the VMs will be typically more than 8 vCPUs in any of the customer base. Let it be even highly utilized data center also. This will be a normal norm that is followed in data centers across. So I would roughly take an average like 4 vCPUs per server, and let me put 800, and let me take the memory as like 8 GB memory per host, which is 1600 GB. And my total storage utilization, let's say per VM, I would need roughly around 100 GB of storage. So roughly this comes to around 20 terabyte of storage is what I am expecting. So let me make it 2480. If the customer is looking for stress cluster, which is 99.99% availability, you can click on stress cluster. Otherwise, you can just click on get recommendation. It immediately says you would need 4 hosts to be available on VMC on AWS, which gives you roughly around 2 terabyte of capacity and roughly 40 terabyte of raw storage capacity, 2 terabyte of RAM capacity and roughly 41 terabyte of raw storage capacity. And this is based on i3 instances. Optionally, you have an i3 EN as well. That is typically if the customer is looking for heavy storage and heavy IO kind of workload, then maybe you can choose i3 EN, but ideally stick to i3. And it immediately says you what are all the information that goes beneath it, like how the workloads can be consumed, what is the free, how many cores is consumed, how many will be free, how many memory consumed, how many is free, and the storage utilization as well with respect to dedupe compression. So what happens is by default, it takes certain assumption in place. 1.5:1 is the deduplication compression ratio. And RAM ratio, we ideally take 1.25:1. This is typically by default it takes. if there is a need, you feel that you need to change it, you have an option to get into the advanced sizer. In advanced sizer, you will get an option to fine tune all these settings. So what would be the ideal deduplication compression that you can expect from a vSAN cluster? For general purpose workloads, if it is more than 3 nodes, 3 node, I would say 1.5:1 is okay. I've seen customers getting 2:1 as well, but 1.5:1 is really good. But once you have a 4 node and above, you can easily size it 2:1 and above. 2:1 is a very good benchmarking that you can take when it comes to deduplication and compression. And for memory, 1.25:1 is a very good number. Don't go beyond it. But in terms of memory and in terms of storage, if you get into the advanced option, you will have the option to say what is the amount of IOPS that you need, etc., etc. And apart from that, you have an option to get into global settings where you can say what will be my SDDC appliance size. What is the SDDC appliance? By default, vCenter, everything gets deployed on the same VMware cluster on the cloud. So do you want it to be regular or large? It's something that you can decide. Typically for a 4 node, 3 node cluster, regular is good enough. Whether you want a stress cluster, yes or no. And in terms of fault tolerance, whether you want RAID 1, RAID 5, RAID 6 is something that you can do here. I would say keep it auto so that it automatically chooses the RAID basis the number of nodes getting added. And a small CPU headroom is something that you can factor so that you don't run at 100% capacity at any given point in time. That is something that you can change here. Apart from that, you also have, just a minute. Let me just have this option. Yeah, additional options. You have an option to set what will be your CPU utilization post this infrastructure. That is, if you say, for example, today, as in your existing environment, I'm running a 4 vCPU average VM, and all these VMs are utilized at 30%, for example. That is the value that you have to put here. Similarly, what is the memory utilization that you are seeing today with respect to VM? And the deduplication and compression is all changeable here. And what will be your IO pattern is also something that you can change here once you have the access to additional, once you get into the advanced sizer. Quick sizer doesn't have any of these options. Does that sound clear? Any questions till now?
Good from my end, Girish.
Yeah, thank you. So once we do this sizing and other steps, I don't know, somewhere it got. Yeah, it's here. Once we do this sizing and we get a recommendation, if at all you want to work on the TCO, you have the option to build your own TCO in the same page itself. TCO is slightly a big task that we have to do. So take support from us or maybe from the respective account team or the VMC specialist in your specific region. You can contact either me, I will get you touch base with them, and we can actually work on a detailed TCO analysis for the solution that we design, so that when you go back to present to the customer, it's not just a recommendation, but also the TCO savings that he will get when compared with this on-premises is something that is possible within the same size. Hope that was clear and it made sense. If at all you have any further questions, this is only an exploratory session. If you want to have further more deep dive sessions into sizing and want to understand better, let us know. We will schedule a one-on-one session within your organization and take it forward as well. We just want to use this platform to give you a brief overview on all the offerings that we have currently. You all are aware about migration, right? We have been doing migration, at least in my career, I've been doing it for almost like 20 years. There were on-prem migration, then people spoke about database migration, storage migration, then came the OS to OS migration. In SAP world, they call it as non-Unicode to Unicode conversion. There are multiple types of migrations that we have been doing. And one that added to the list over the past 10 years or maybe 5 years is actually the cloud migration as well. And when we speak about cloud migration, there are multiple options. There is something called as 5 hours, or maybe some call it as 7 hours as well. Let me stick to 6 hours. First one, obviously, customers who want to just migrate their applications assets to cloud. Either there are the crude way of calling it as lift and shift. Certain people call it as rehosting. That is one of the hard. Second is customer who are saying, I don't want to migrate to cloud at all. I want to retain it within the host, within my existing on-premise itself. That is where the second R comes. People call it as retaining as it is. So rehosting is lift and shift to cloud. Retain is staying wherever they are. Third, customer says, I am already on cloud. I may want to try out some cloud services. I'm matured enough. Maybe some small changes to my applications and other stuff may work. If that's the case, people go and do something called as replatforming, or in VMware terms, we also call them as hybrid apps, where certain component of the application runs on VMware Cloud and certain component runs on AWS native services like RDS or maybe a Lambda kind of workload. That is.
Girish bhai, your slides are not moving.
No, I'm not yet moved. I'm still on the.
All right.
So this is yet another option. And the other option that customers do choose is like, I want to completely transform and go the cloud native way. That is when refactoring comes into picture. Another R where they speak about converting their monoliths into cloud native applications and use containers, serverless, all these stuffs are something that comes into picture. And the last R is where customer says, okay, I just want to exit out of every data center. I don't want to manage anything. Let me get into a SaaS kind of a model. That is where app retiring comes into picture. So these are some kind of R's or migration that we predominantly speak in cloud world. When we speak about VMware Cloud, the most important migration that we speak is helping customer to arrive on cloud. That is land on cloud safely, faster, with minimal efforts, so that even if he doesn't know anything about cloud, he should be able to manage and land on cloud. That is exactly the VMware's USP is all about when it comes to VMware Cloud. And for that, rehosting is the immediate option. And for rehosting, today there are plethora of tools. But whenever you speak about any tools to native cloud, there is a conversion that is needed. They have to convert, say for example, VMware has VMDK, but when we speak about AWS, it is all AMI images. So there is a conversion that is needed. So you have to use certain tools to convert, downtimes, etc., etc. How can we reduce all these particular efforts? Customer use whatever they see. For customer today, when you speak about migration on premises, they will always say right click and migrate, which is vMotion. Can't we do similar stuff so that we can land on cloud seamlessly? That is exactly what VMware's cloud migration is all about. And what we use here is a product called or a tool called HCX, which is Hybrid Cloud Extension. And that is what we will be seeing in the next half an hour to 40 minutes. Workload migration. So when you go and speak to a customer for migration, it's a large project by itself. I have pulled out a couple of migrations in my 20 years career till date. As complex as migrating from non-Unicode to Unicode kind of SAP to just simply mirroring a disk and giving it as a migration. I've done almost all. So what I've seen with respect to customers is, number one, when I'm migrating from one cloud to another cloud, these two clouds are completely interoperable. How will I be able to migrate? That is the first barrier that they are saying. I have to change, right? And I don't like change. I resist to change. If that's the case, first challenge is with respect to the compatibility. Second, I'm migrating everything from here to there. But what about my networking and security? I have to reconfiguring everything. There is something called landing zones in cloud that you have to configure. And after the landing zone, you have to configure the security parameters. Many stuff comes into picture, right? That cross-site networking and security issue is another issue. because of which there occurs a downtime as well. Customer has to plan for it. And it's not as simple. It has multiple facets to it. Third is application dependency mapping. I cannot just migrate one workload. I have to migrate the entire application together. I cannot have something running on cloud and something running on on-prem. It may induce network latency. Third issue. And the fourth is adding all these things, there is a disruption to my business as well. These are some challenges that customers are facing when it comes to migrating to cloud. Now, how do VMware help you? So that is where VMware says we can provide you multi-cloud with a bit of hybridity into it. And the main ingredient that provides the hybrid nature to customer is actually HCX, hybrid cloud extension. Let's speak about what is HCX. So customer has an on-premise data center, and VMware current version is vSphere 7.0 U2. Even if the customer is having vSphere 5.0, which is 2 generations behind and 10 years before. 5.0 was launched in 2011, so 10 years before. Even if the customer has such a kind of vSphere, he is still applicable and he can be taken to cloud as well. And now, once customer sets their VMware cloud, here it is written as AWS, but for a moment, forget AWS. Think it as any of the hyperscaler. Let it be Oracle, let it be Google, let it be Azure, whatever we have spoken. Everything is applicable. No matter, it doesn't need to be AWS only. What customer can do is, customer can choose HCX as a service available from the cloud. It is by default available for every customer choosing VMware Cloud. If he chooses VMware Cloud subscription, HCX is by default available. You can just go there and activate. What happens is HCX deploys the infrastructure that is required, and it creates an abstraction layer between your infrastructure, which will take care of your interoperability issues, so that you don't need to worry about whether my cloud is interoperable with my on-premise. Cloud can run on 7.0. My on-premise is running on vSphere 5. It is still compatible. Second is, it will provide the connectivity from on-premise to cloud and create all those WAN optimizer, the VPN tunnel, load balancer that is necessary to ensure that it uses your link, the direct connect link or the VPN link, to the maximum. This is the layer that provides you the hybridity and extends your on-premise network to cloud, which means I am extending your L2 domain. Say, for example, you have a CIDR range of 10.0.0.0/16 on-prem. I can actually extend the same CIDR to cloud as well and create a 10.0.0.0/16 and allow them to communicate over the tunnel that is created by HCX. That provides the hybridity. And last is, we can provide option to bulk migrate. Say, for example, I was speaking about application dependency. I cannot just migrate one application, one VM. There might be some 10 workloads that has to move together. HCX can provide you with such kind of seamlessness to ensure that we can migrate 10 or 15 workloads together to cloud without taking a downtime at all. And once it is on cloud, it will continue to use the same IP address, same networking and security policy, and connect to the egress traffic from the cloud outside, which means there is no business disruption. This is exactly what VMware HCX in a nutshell is. And HCX as a tool is not just supported for cloud, it is also for on-prem to on-prem migrations. Let's look at what are all the use cases that we have with respect to HCX. Now, HCX as a tool will allow customers to migrate from legacy data center to the modern data center for a kind of retain kind of a migration where he wants to stay on-prem, but he wants to migrate to a new set of hosts. HCX can help customer migrate. Apart from that, HCX also helps customer to migrate from on-prem to cloud or from cloud to cloud as well. Say, for example, customer is running on VMC and AWS, and suddenly he wants to shift his workloads to Google or maybe to Azure. He can use the same HCX tool that is available and lift and shift the application from AWS and land on Google as well. And completely seamless. There is no downtime when this migration is happening. and the user access will still continue. That is exactly what HCX can provide. Now, let's speak about certain use cases that we have seen in the past with respect to certain customers. I have marked the customer names. This is all some global customer references that we have, internal references. I masked the customer names, but let's get into the use case, what all HCX have done for customers till now. There was a customer who had multiple data centers, some 3 or 4 data centers across, and he wanted to merge them all into a single on-premise data center. This is not cloud, on-premise data center. What he did was he deployed HCX on all his data center, the new data center and the old data center, and then created a tunnel between the data center and seamlessly migrated workloads to the cloud. What happened is they were able to migrate somewhere close to 1,000 workloads in just 3 weeks. 3 weeks, their entire multiple data centers were shut down and they had consolidated to a single data center. What was the benefits that the customer said? So one is ROI TCO went up because he was able to shut down his operations on all the remaining data centers as soon as possible. Second, business impact was nil. And third is he was able to successfully transform his entire data center, which was one of his business goals. So that way, HCX was useful for this customer. Second use case that we have seen with respect to HCX is with respect to VMC, VMware Cloud on AWS. There was a customer, what he wanted to do was he wants to migrate the entire on-premise data center to cloud and then use the on-premise data center as a DR site, that is protect back. So he wants to have a DR on-prem and protection running on VMC. HCX was used to migrate. They migrated using HCX to cloud, and the same HCX was used as a disaster recovery tool as well, or a disaster avoidance tool, just like you might have heard about VMware Site Recovery Manager, right? HCX can operate like a Site Recovery Manager and integrate with Site Recovery Manager as well for orchestration. So that is what he did. He used HCX as a migration tool and as a disaster recovery or an avoidance tool as well. Both use cases were sorted out by this customer. So what happened was, number one, a large scale migration, yet again, another use case that we were able to see. Second, IP was preserved. Whatever IPs that he had on-prem was preserved on VMC as well, so that there was no downtime at all. And third is complete data center, on-premise and cloud, were L2 extended, so that whenever he called for a DR, whenever the workload came back and ran on the DR side, it ran with the same IP address, which means the RTO also came down. Because what happens typically in a DR is when you call a DR, you have to change the IP address of the nodes in the DR. Now, when you change the IP address, the applications will change, which will impact your RTO. Here, since the IP address didn't change, there was no impact to the RTO at all. RTO almost came down by 60% to this particular customer. The RTO, which used to be somewhere close to like 4 hours or 5 hours, came down to roughly an hour for his entire BCP-DR use case. That is exactly what we saw as a use case to one of his customers who is in Canada. Another customer, this is a customer in Europe. Customer had multiple data centers and multi-cloud environment already, and he wanted to have all these things speaking with each other in a mesh kind of an architecture. What HCX did was HCX allowed customers to actually mesh the communication across all these particular cloud in a one-to-one mapping model. So that what happened is all these 4 clouds were managed from a single console. So this gave a true hybrid architecture to customers. So the customer, whenever he wants to migrate a workload from on-premise to any of the cloud, he has to just right-click and say migrate. And when he wants to pull it back to on-prem, he can just migrate, right-click and say migrate it back to on-prem. That way, he was able to create complete hybrid cloud strategy. And if you see here, the versions that they had was also different. VMC was running on vSphere 6.7, IBM was running on vSphere 6.5, and VMware Cloud Foundation was running on vSphere 7.0. So if you see here, it was also different versions of vSphere that we are speaking, but still customer had hybridity in nature, and all the data center extension in terms of L2 extension is all was all being configured for this customer who was in Europe. Let me get into one more. This is predominantly another use case which will be more relevant for you, where you might ask, okay, I have customers who are running multiple clouds. Can I use HCX to actually have leverage connectivity across these multiple cloud vendors or maybe multiple regions? If that is the case, we have a use case for that customer as well, where customer wanted to have DR on another region, and he also since VMware Cloud was not VMware Cloud on AWS was not available in a specific region, he wanted to choose Azure for that particular region, and he wanted to have interconnection between all these three clouds, something that we have achieved today. So he was able to have DR running on VMC on AWS and an extended data center running on Azure, so that even if Azure AWS fails for some reason, he can operate the remaining workloads from Azure as well. So and he was able to move workloads across cloud and across cloud regions as well. I have a couple of questions. Let me just answer. Oh, Purushottam, you have answered them. Thank you.
One question here, Girish. So can we use, I mean, sometimes customer asks, can we use HCX directly to migrate from on-prem to directly to AWS, or it has to go through via the phase-wise manner? It has to be refactored, go first via the VMC on AWS and then go phase-wise onto the AWS.
HCX is typically for anything to VMware. Anything to VMware. So say for example, I'll cover that use case as well. If the customer is running a native AWS or a native Azure solution, you can use HCX to migrate them to VMware Cloud. Or if the customer is running something in on-prem like a physical machine or maybe a Hyper-V stack or maybe a KVM stack, HCX can support that as well. But HCX cannot migrate to native clouds. HCX only supports migration to VMware Cloud, because otherwise the entire use case becomes irrelevant, right? We are hybrid cloud, and if you bring something else, then all this interoperability comes into picture. And this is specifically for all those customers who are running VMware environments in their on-premise data centers to be able to get it to cloud as fast as possible.
Okay, so Girish, what you are saying is, we will not be, if I take the same case, there are some solutions running on-prem, running on VMware. We cannot directly use the HCX to migrate those VMs to AWS like an EC2. It is not possible. So it has to first sit on the VMC on AWS, and then gradually it can be moved maybe into the EC2 cloud native solutions. That has to be worked out separately.
In that case, you need to convert the VM format, because on the VMC on AWS, the format is same. The ESXi format will be there.
Understood. So if we have to maintain the same without touching any production environment, so we have to go on VMC on AWS.
Yes, because that is what the customer's challenge is today, right? When customers pick, that is the main value proposition that we bring to the table. We are saying the customer, you don't need to change your format at all. You can just move it as it is to cloud. And then from there, what you need is all those access to those native cloud services, which we can allow you to access. So what happens is there are certain, tomorrow we will speak about certain reference architectures where we can integrate certain services with native cloud services as well. We have a session, a 45-minute session, where we will speak about all these reference architectures.
Right. So why I ask this question, Girish, maybe for every other people as well, because we work on the other side of the migration in the public cloud. So we use the cloud endure. Okay. Yeah. So we bring those VMs into the EC2 format. So sometimes we work on the complete rehost, that is lift and shift. Sometimes we do the replatform. But we use the cloud endure methodology there.
Yeah. So here, instead of cloud endure, what we are saying is you can use HCX, and you can use HCX as an ongoing tool. Instead of, when we speak about custom cloud, right, enterprises moving to cloud, at one point in time, they also want to bring back certain things from cloud.
Yeah.
Cloud endure will help customer to move, but bringing back will be a challenge. Or if they want to exit from AWS and move to Azure, cloud endure may not help them. But what we are saying is HCX as a single tool will help customer to migrate to cloud to cloud, and bring back them to on-prem if there is a need as well.
There is a need as well, and if they want some kind of extension from their on-prem to AWS, the cloud, so they can use the HCX.
Extension, yes. In case of like, say for example, I'm just doing my vMotion. The customer is using this as a burst use case, where I will migrate my workloads to cloud for time being, use the resources there. Once the burst is over, or burst period is over, I'll just bring it back to my on-prem. If that's the case, HCX can support there as well. So if you see in this entire use case, what we are saying is you don't need downtime at all.
Right.
Migrate and seamlessly come back. So there is no business disruption. That is the main value proposition that we have to put in front of the customer when we speak about VMware Cloud. And what it brings is, if you, since there is no downtime and other stuff, it is the fastest path to cloud. Otherwise, if you say that we need a downtime, customer has to plan for the downtime. And downtime is applicable only maybe Saturday, Sundays. And since today data centers are all 24/7, they have to plan application by application. Here, since we are saying that the downtime, there is a downtime based migration as well, minimal downtime based, and there is a without downtime based as well. Whichever the customer chooses, it will be very minimal time that will take for, in between for you to just send the data to cloud. So what happens is customer need not plan all those downtime, and they can get to cloud as fast as possible. Say for example, we have a customer who migrated 2,000 workloads in 5 weeks. And almost 250 applications, where each application was roughly around 50 VMs within a year. Within a year, this entire data center of 250 applications went to cloud. That is all something, if we look at a traditional cloud, native cloud vendor, this would not been possible, because each application you need to take at least downtime during a weekend, and we have only 52 weeks, which means 250 applications to move to cloud. It's not going to be within 1 year. Even if we take more than one application in a weekend, definitely it's still not possible. But with VMware, this customer was able to migrate 250 applications in just 1 year. So that these are some USPs that we would want you to propose to your customers when you see them wanting to move to cloud. And in this thing, whatever help that you need from us, or from AWS, or from the respective cloud service provider, will be there for you.
Yep. Well, one last question, Girish, around the bulk migration. And you mentioned about one good thing about it maintains the IP from what it carries in the on-prem to the VMC solution.
Yeah.
What network it should be, whether it need a special network like NSX or something, or it's okay if we have the distributed switches and all this.
Even a standard switch is okay, to be very frank. So how it happens is, say for example, if the customer is using HCX, HCX will do the L2 extension. HCX will do the L2 extension of your on-premise data center to the cloud. So what happens is, whatever IP address you have on-prem will move as it is using this L2 VPN tunnel to the cloud. And HCX also has something called proximity routing. When you say proximity routing, after the VM goes to cloud, typically in a VPN, what happens is, the VM, if they want to speak outside, their transit will be all the way via the VPN to on-prem and then go to the internet, right? That is how typically it happens on a cloud world, on a typical VPN world.
VPN world, yeah.
Yeah, with respect to HCX, what happens is, after your VMs migrate to cloud, the proximity routing will point your VMs to use the router that is nearby and then take the exit outside. So what happens is, you don't need this tunnel anymore after the migration.
Understood. So it goes by the gateway of AWS part, which is there.
Yes, you don't need NSX mandatorily on-prem. On-prem can be as simple as just vSphere running on it, but HCX will provide all the capabilities that is needed. For connectivity to cloud, obviously we can either use a direct connect, you can use a L2 VPN, which is by default available as a part of NSX itself. So you have NSX on cloud, where you can go and download a small OVA file. The OVA file is a standalone gateway that you can deploy on-prem and create your VPN link between these two sites. That is also possible. Third, you can use the SSL VPN that is applicable in the AWS world. That is also supported. So, or you can, if the customer has an MPLS, we can use the same MPLS and connect it to the last mile connectivity can be provided by direct connect as well. So all these multiple options are available when it comes to connectivity to cloud, and the extension of the cloud and networking is taken care by HCX or by NSX. We don't need anything on the on-premise. It will all be deployed as a part of the service itself. Hope that answers.
Yes, Girish. Like we have the Sizer. When we get into answering customers' migration related questions, do we have anything where we can get some idea? Like suppose they will say we have 100 to 200 workloads and we need to go bulk migration, and it will require 3 weeks, 4 weeks, 5 weeks of timeline for the migration.
Yeah, we do have. I will connect with you one-to-one and let's explore it. We have certain types of options. We have something called migration waves that we have to plan, but it is typically dependent on the bandwidth that the customer is going to provide.
Understood. Sure, Girish, I will ping you here.
Yep, thank you. So on the whole, HCX provides multiple capabilities. Number one, it is an hybrid solution. It connects two distinct data centers together. It provides its own WAN optimization service, which means when you are actually trying to migrate from cloud to on-prem or cloud to cloud, the egress charges will actually minimize because of the WAN optimization, which might not be possible using the normal tools. Third, it provides cross-cloud vMotion migration. So you can just right-click on the VM and do a vMotion to cloud. But vMotion is applicable only for 8 VMs parallelly, concurrently. So customer might need multiple VMs to be migrated together. That's where bulk migration comes into picture. But in terms of bulk migration, maximum is 100 VMs in a single wave is what we can support today. And there is a small cutover time that we may have to factor when it comes to bulk migration. If the customer says, no, I cannot afford any downtime, we do have something called replicated assisted vMotion migration, which is nothing but the mix and match of cross-cloud vMotion and bulk migration service. You can migrate 100 VMs at a time seamlessly without any downtime. That is what is replicated assisted vMotion. We can do network extension for ongoing operations. We can use HCX as a disaster recovery and a disaster avoidance service as well. And the last important feature of HCX is it also supports something called as OS assisted migration, which means if you don't have a VMware infra and if you have something else on the source, we can even migrate those workloads into VMware Cloud, on VMware Cloud or into VMware infrastructure as well. That is also something that HCX can provide. So HCX by default, whatever is offered as a part of cloud is HCX Advanced. By default is HCX Advanced. There are certain use cases or certain features that is available only in part of HCX Enterprise. If that is needed, customer can ask for a add-on service, and add-on service will be only for the subscription period. Maybe you can use it only for the migration time frame for 1 month or something, and then you can get rid of the service. That is also possible. So as a part of HCX Enterprise, 3 features are available. Number one, if the customer is looking for non-vSphere bulk migration, go with HCX Enterprise. If the customer is saying I don't need bulk migration, you can do a normal P2V kind of a migration. HCX is not needed. Downtime is available and bulk migration is not needed. You can even go with the normal P2V conversion supported. But if the customer is saying bulk migration of non-vSphere, then obviously HCX Enterprise is needed. Second, bulk migration with live migration, replicated assisted vMotion that I was speaking about. Again, it is also part of HCX Enterprise. And the last is if the customer is looking for a disaster recovery or disaster avoidance, HCX Enterprise is mandatory for these 3 use cases. So, how HCX migration is performed? There are 5 types of migrations that we typically perform using HCX. One is cold migration, where customer says, I will take a proper downtime and allow you to migrate. Where while the migration, VM will be off, and after the migration, you just power on the VM. HCX vMotion, completely live, no downtime, but at any given point in time, only 8 VMs can be migrated. Not more than that. 8 is the maximum limit. Bulk migration, it is 100 VMs will be migrated together. You have the option to perform incremental updates and other stuff and all. And when you feel that it's the right time that no more increments, you can just call for a cutoff and then power on the VMs, fail over the VMs on the cloud, so that the downtime will be very minimal. The data, while the data is getting replicated, there will be no downtime at all. It is only after the data gets replicated, you need to take a small downtime, perform the smaller incremental updates that would have occurred after the last update, and then bring up the VM. Third is bulk with OS assisted replication. This works in tandem with, it does vMotion, storage vMotion, everything in parallel. And it works for 100 VMs at any given point in time, which means you can just schedule for 100 VMs in the night, and in the morning, you will see all these 100 VMs running on the cloud. Seamless. We will show this demo to you tomorrow during our demonstration class. It is at 10:45. You will see this demonstration. And the last is replicated assisted vMotion. Here we will be speaking about replication assisted is all that without downtime. Bulk migration with OS assisted is all about migrating the non-VMware assets in the customer's data center. Again, there is a downtime for non-VMware assets, but that is only the downtime that happens during the VM to be powered on the other side. It is equivalent to the bulk migration. No difference to it. So this is how the scenario works when it comes to online migration without any downtime. When you start the migration, it does a full sync of your data to the cloud, and then it will immediately start a continuous sync, the incremental updates. When the continuous sync ends, you can call for a maintenance window. When I say maintenance window, it's not a downtime. This is a maintenance window that is automatically called in by your HCX. No downtime. Downtime doesn't happen. It is just a trigger that happens. After this trigger, the VM will take a snapshot. The snapshot of the VM will get replicated. Then it will disable the replication, and then it will prepare for something called as a vMotion. The vMotion will migrate all your delta changes that is there in the memory and on the storage. And once your delta vMotion is completed, it will copy the memory state and then do the switchover of your VM to on-prem. Completely a very complex process, but we have made it very easy for the customer to just right click and say migrate. In the migration option, all these things are taken care by HCX itself. When the migration gets complete, the VM, however it was in the state in the DC with respect to IP address security policies, will come up as it is in the cloud as well. And there will be no downtime. Users will not even come to know that such a migration has occurred. That is the USP of this particular replication assisted vMotion.
One question, Girish, around if we are migrating a database related kind of thing, how about the continuous writes or changes happening around that? How it maintains its state during the replication and non-replication cutover?
So when we take a snapshot, our snapshots are VSS based as well. Volume shadow copy service based. So it has a bit of application consistency. But if you feel that the customer uses application which is not compatible with VSS, then obviously go for bulk migration and not for replicated assisted vMotion.
Okay, bulk vMotion.
Bulk migration will take a small cutover time. There will be a cutover time of 9 minutes or 10 minutes that you can take, where you can shut down the VM on DC and bring up the VM on DM.
Okay, so that should be a planned downtime, and then do the bulk migration. Understood.
Yes.
So in those cases, we need to be very planned which kind of workloads we are using with the replication option and which are not.
Exactly. I will cover that in the last. Actually, there is a slide for that. I'll cover that. How to plan for the migration. So and we can have detailed discussions on these migrations one-to-one within your organizations as well. Just let us know. Second is site recovery. You all know VMware Site Recovery Manager is a BCP-DR orchestration tool which allows customers to call for DR, do a DR drill, etc., etc. HCX by itself is a DR tool. It can do the replication and it can integrate with SRM. what happens is the replication happens via HCX, which will be which has WAN optimization and other stuff, so that the egress data will be very small. Replication, compression, etc., happens. Data is encrypted during replication, all those stuff. And SRM will only do the automation or the orchestration part of shutting down your VMs on DC and bringing up on DM. That is something that SRM takes care of. And these two are integrated to provide both these functionalities together. Next is what is the benefits of HCX by default? So if you see, when you say HCX and SRM together, one is the benefit of HCX and SRM together is, number one is WAN optimization. So obviously the network traffic bandwidth would be that would be needed to replicate will be minimal. And second is the egress traffic charges also will be less. Second, it is completely encrypted, which means the DR traffic is completely secured. Third, it provides L2 extension of your network, which means there is no need to re-IP or modify your IP of your workloads after bringing up in DR. It comes up with the same IP address, and the proximity, HCX proximity feature will provide routing from the data center or from the cloud wherever it is necessary. It provides a complete disaster avoidance. So because if you feel that there is a disaster going to come, you can just right click on the VM and do a vMotion. So it will be a disaster avoidance tool which will not inflict any downtime at all. Supports all the flavors of NSX and DDS also on-prem. And last is the proximity routing, which will provide the access, the egress access for the VM from the DR side. So these are some capabilities and the benefits that HCX can provide along with site reporting. This is, by the way, this is an add-on service. This is not by default. If there is a need, this can be proposed to the customer. Hope this is clear. And HCX provides something called as mobility group feature. This is where bulk migrations will be helpful. You can say you can create a mobility group of all your workloads for a single application put together, and then make a batch so that they move together, they replicate together. So that what happens is whenever you move an application, all the workloads in that particular application will move to cloud. And the dashboard, whatever we see, will be all applicable basis the mobility feature. If you see any of the current system, you don't have this option to put multiple workloads together and group and batch and send them. It will all be individual replication. Here, you have the option to create something called mobility groups as well. So what is HCX on VMC? Pretty much the same. Only thing is HCX is provided as a service on VMC. If you see more or less, it is all the same capabilities and other stuff. It is just a service on VMC. Customer has to go to the cloud console and say activate. Once he activates, HCX Cloud Manager is a VM that gets deployed on the cloud. In the Cloud Manager, you will have an option to download something called as an OVA file, which is nothing but an HCX connector. Get this HCX connector deployed on the on-prem. This is a one-time activity. Once you deploy the connector, you can pair the connector that is deployed on-prem with the Cloud Manager on the cloud. Once you pair, the tunnel gets established, the WAN optimizer service gets established, and that's it. This is the HCX setup that you will be doing. You don't need separate license on-prem. It's the same license that you have on cloud, which comes as a part of the subscription. Now, once it is done, HCX provides the interconnect, and how it supports on-prem. The versions can be anything. vSphere version can start from 5.x. It can go up to 7.x. Every versions are supported. Network, we can support NSXT, let it be NSXV or BDS, which is distributed switch, or a standard switch, or even the Cisco's Nexus switches are also supported as a part of the networking topology. And in terms of storage, it can be as heterogeneous as possible. It is not mandated that it has to have a vSAN there. It can be local disk, you can have iSCSI, you can have NFS, you can have FCSAN, anything, everything is supported on on-prem. You can just do the VM migration, and once it comes to on cloud, it will follow whatever is available on cloud. And all those capabilities of WAN optimization, deduplication, compression is all inbuilt, and you can enable it as per your choice. Maybe you can enable it, or you don't. If you want to skip it, you can skip it as well. And for the HCX interconnect, what we recommend, obviously, direct connect is always better, because if you want to bust workloads to cloud as an for a data center expansion, AWS Direct Connect is better. But if you are just planning to do a DC evacuation and just do a migration, then obviously anything above 100 Mbps connection should be good for HCX, because vMotion needs a minimum 100 Mbps link. That's the reason 100 Mbps is the bare minimum requirement for HCX. So HCX supports all the 5 migrations, and if you see here, downtime is applicable for cold migration because it's completely down when the migration is happening. vMotion, absolutely no downtime. Bulk migration, minimal downtime for that cutover period. Replicated assisted vMotion, again no downtime. And for OS assisted migration, there is a small amount of cutover plus conversion downtime that happens at the post migration. So very small. It's not like very huge time. It will be incremental time above the normal minimal downtime. And HCX can also used for customers who are looking to have a cloud to cloud kind of a connectivity. The diagram that you see in front of you is all AWS. Across regions, you can use HCX. But if the customer wants to migrate from use HCX across Google Cloud to Azure, or maybe Azure to AWS, it is all possible. It is the same effort that he has to do. Only thing is, he will have multiple cloud managers here instead of connector, because he can have HCX activated on both the clouds, right? So 2 cloud managers will be deployed, but still the configuration is all done from single cloud. Once you pair it, whatever you configure on one cloud, it gets applied onto other cloud as well. Now getting into migration, typically we would suggest you to go back to customers and see any of these 5 trigger points. Number 1, if the customer is looking for hardware refresh, if there is a data center consolidation coming up, there is a good amount of organization changes that is happening, new projects are coming up, there might be customers looking for M&A, where mergers and acquisitions are coming up, and due to some regulation requirements. If any of these 5 use cases you are able to see in your customer base, VMware Cloud and HCX makes absolute and beautiful sense there. And we want you to uncover those opportunities and let us know so that we can participate and work with you in converting that opportunity into a use case for VMware Cloud. So look out for these particular trigger events mainly. And what HCX, when we say completely, if you see most of the solution, what HCX is providing, in a real world, you have to build it yourself or use some specific hardware like OTV, which is provided by Cisco, to actually get rid of those particular, to have those particular functionality. HCX, if you see, it's a single tool which can provide most of the capabilities that is typically needed for cloud migration and typically for rehosting capabilities. It is completely unmatched with whatever is provided today in the industry. So this is something you have to take it as a value proposition to your customer when they ask about why VMware Cloud migration. This is the main use case that you should put in front of. And when we speak about migrating, 3 specific steps is what we will look for. Number 1, extend your network, as I told you. Extend your network, then evacuate your workloads, completely move to cloud. And for moving to cloud, you have an option to create something called as mobility groups, so that each mobility group can be planned as a migration wave. How you can select the mobility group, it is entirely dependent on you. It can be either dev, UAT and prod kind of workloads, or it can be applications specifically, or it can be based on customer's use case, whatever it is. That can be decided upon landing the project. Last is, once you migrate, you can actually have all those firewall rules, everything that needs to be configured can be configured as a precursor to your migration. And then once it is migrated, it can use all those firewall policies. Whatever you had on premises can be used from cloud as well. Now, when we speak about migration, I would ideally say put it into baskets. We call it as basketing, right? In terms of cloud migration. So typically low-hanging fruit will be dev and test. Then you can get into production, which are easier to migrate. Then you may test the more robust and the complex migration stuffs. Always start with the low-hanging fruit, which is dev and test or kind of workloads. And when you speak about migration, we call something called as a wave. Each wave are you as 8 of these particular process. Number 1, plan the wave with what are all the mobility groups involved, which mobility group will have which particular application, how the application dependency mapping. These are all something that you have to plan before the project starts. Second, do the network configuration on the cloud with whatever you need. You can term it as like a landing zone configuration, something of that kind. Then extend your network from on-premise to cloud using XCX. Then do some pre-flight test by migrating some workloads. Maybe you can use some speedometers to test the speed, etc., etc. Then migrate all the low-risk VMs. While migrating the low-risk VMs or low-key VMs, you might not need a AWS direct connect. You can use even a VPN with a shorter bandwidth pipe, so that you can be efficient and do all your testing with the development. And once you are satisfied everything is fine, maybe then you can apply for a direct connect, or maybe increase your bandwidth to shorten the timeline for your migration of your production, and then start the migration of your production application. Once you migrate on the cloud, make all those necessary fine tunings, and then release the application to your customer. So these are the 8-step process that we would suggest whenever you plan for VMware Cloud migration. And what you do is, whenever migration is planned, it is planned in something called as waves. This is typically for bulk migration, where a small amount of downtime would be necessary. You can do an initial sync for multiple VMs within a wave. And once the VM replication is all done and the incremental sync is completed, you can take your maintenance window, do the change block replication, the final replication, and then switch the target and bring it up. And if you see, the downtime is only here. This is only for this particular place. And this particular place, when the data is getting migrated, there is no downtime at all. So if the data is taking 7 days to replicate, for these 30 VMs, what we found at one customer places, around 90 minutes, 3 minutes per VM is what is the downtime that we took for the entire 30 VM migration. So all these 30 VMs can be planned to migrate and switched over together, or it can be separate VM as well. Here it was separate VMs. We call it as a long pole stage actually. And similarly, you can—
Sorry, if you go back, Girish, yeah, this is bulk, right? I mean, all 30 VMs at once or one by one. I mean, I didn't got.
So, this is all 30 VMs at once. All 30 VMs at once. But if you see, all VMs may not replicate and complete together, right? One of your VM might be only 50 GB, it completes in a day. One VM might be 1 TB, it takes around 5 days. Something of that kind. So that is where, if you see the initial sync, the time taken by each VM is different. But at last, what we can do is, once all the replication is complete, and if you see them in ready status, that is when you can plan for the maintenance window and then do the cutover. So here in this particular customer, the cutover was not as simple as cutting over all 30 VMs together. He wanted to do one by one VM because there were certain updates, patches, whatever that was necessary for him to do before he gets to cloud. So he did it one by one VM. That's the reason it took 90 minutes. But if the customer is saying, no, I want to cut off every VM together, 30 VMs together, it might take only 3 minutes for all the 30 VMs to come up on the VM.
Basically scheduled. Is scheduled.
Yeah. Yeah, it can be scheduled. So similarly, you can plan for multiple waves, and believe me, 100 VMs per wave. It cannot be more than 100. We don't support it as of now. 100 VMs per wave is what we support, and you can actually create a project plan with respect to what is the data utilization data that you want to migrate, what is the bandwidth that they have. Maybe you can factor in WAN optimization benefits, at least 25 to 30% is given. You can factor that WAN optimization benefits and then come up with a value that you can provide to the customer as a part of the project plan. So this is something that we can do as a part of our service catalog that we have agreed, and give it as a part of the project plan as well. So that's it from my side with respect to cloud migration and HCX. If you feel that there are more questions to be answered, or if you want to take it further and have detailed discussion, do let us know. We can have a one-on-one with your organization as well.